Good evening, everyone. Before I introduce our speaker, I want to thank our sponsors, the Westin Long Beach Hotel and Gazette newspapers up here. Tonight's a very special night because I'm going to introduce to you our very first, and I hope it will be an annual program, Distinguished Visiting Scholar. And I can't think of anyone better to kick off this new program than Daniel Botkin. He's a professor emeritus from the Department of Ecology, Evolution, and Marine Biology at the University of California, Santa Barbara. And this program that we're creating, it's an opportunity for our staff, our members, and the extended community to interact every year with one of the best minds in the world. And Daniel Botkin has a bachelor's in physics from the University of Rochester, a master's of art in English literature from the University of Wisconsin, and a PhD from Rutgers University in ecology. He's widely known for his writings and his talks on far-ranging topics. And he exemplifies, as well as anybody I know, the life of the mind, which people in universities like to talk about. He loves exploring ideas, challenging conventional wisdom, working across disciplinary boundaries, and making new and innovative connections where others have failed to see those connections. He has a restless curiosity and a wonderful capacity to synthesize information from diverse fields and bring them to bear on solving problems or illuminating new areas of interest. But he has worked on, for example, finding a solution to Mona Lake, salmon, and a number of others that I will hope he will talk to you about. And when you look at that background, you just wonder about this guy. And when you get to know him and the surroundings that he grew up in, it all begins to make sense. He was born in Oklahoma. His father was a professor at Oklahoma. Most of his growing up, though, was in New York at Croton-on-Hudson, which is a wonderful small community along the Hudson. He grew up in a home surrounded by books and music. His father's cousins were George and Ira Gershwin. His father wrote 25 books on American folklore. And as I mentioned, he had been a professor at the University of Oklahoma. And then during the Roosevelt administration, he worked under the WPA, and he was in charge of a series of large oral history projects of America's rivers and folklore. He grew up having interactions with Pete Seeger and Woody Guthrie. And for those of you tomorrow, if you vote early and come tomorrow night, he is going to play the guitar and sing. So he'll let you see that compared with him, Guthrie was just an amateur, right? And Seeger, you better come. But after many years as a leading scholar in academia, I think it was, 39 years in academia, UC Santa Barbara, George Mason, back to Santa Barbara, and then he repotted himself in the Warren Bennis definition of that. He's president of the Center for the Study of the Environment, and he continues to study and to write about all aspects of the environment and the relationships of humans with the environment. He has studied moose, elephants, bowhead whales, forests. He has done some of the most remarkable studies that one can imagine, and I highly recommend his books to you. Do we have any of his books for sale?
I can go find out.
We'll find out. If we don't, we'll make sure that we get some. And as I say, he's also worked on solving problems that have eluded the resolution. And one of these, for example, was whether there should be vegetation in Los Angeles. We talked here in this auditorium that it's a desert, and we should be using native vegetation. And there was a proposal to get rid of all of the vegetation to save water. And he was asked to comment on that. He is an expert at bringing people, scientists, businessmen, other leaders together and having discussions that help find resolution where there hasn't been any. And again, as those of you who are familiar with this aquarium know that's something that we place a very high value on. And so it's Please join me in welcoming Dr. Daniel Botkin, and do try to come tomorrow night. Yeah.
Well, thank you. That was a really lovely introduction. I hope I can live up to it. I can assure you that I'm not up to Woody Guthrie and Pete Seeger, but if you want to hear a devoted amateur, you can come tomorrow. I'm delighted to be here, and I have to say I got here this morning, and I've had a wonderful time. First of all, it's such a delightful aquarium, and as I was saying to the people who took me around, mostly, I deal with environmental issues, and I feel like the world is falling apart, and I come here and get to look at the fish, and it's so beautiful. It's very peaceful and zen-like. And then Jerry and I have had wonderful conversations because about everything, about civilization and culture and the value of people and the value of what people do creatively as well as environment. And that's always been a persistent theme with me and very relevant to what I want to talk with you about today, about the importance of nature, but also the importance of people and civilization. We sometimes go astray. So I'm delighted to be here. I used to begin this kind of talk by quoting Will Rogers, because he's one of my favorites. And you look like a crowd who's heard of Will Rogers. Yeah, well, you'd be surprised college students haven't. But I used to start by saying, what I'm going to tell you, and this is still true, is what Will Rogers said. He said, it ain't what you don't know that gets you. It's what you do know that ain't true. Now, I used to use that. But then Al Gore got it into his movies and got it mixed up and phrased poorly. And now I hear people using it, and then they go on to tell you things they believe that aren't true. So it's still a great statement. Anyway, now I don't usually read my talks, and I'm not going to read all of this talk, but I'm going to talk to you about global warming. And it's such a controversial topic, and I'm going to take a very iconoclastic point of view about it. So if you have to bear with me, but I really have to word this very, very carefully. And so I'm going to read some of it. It's not really my style. I much prefer the Joan Rivers style of interaction on science. But anyway, please also, we're a small enough group that you should interrupt me as we go along and ask questions. I much prefer that kind of context. And I think you look like a lively group, at least now. Maybe you won't be in a few minutes. I just do want to read you a little bit of the beginning of this. And as I say, I rarely do this, but it's such a difficult subject. We live in a time when people want to know what is true and what is right. And the assumption is that these are simple questions with simple, straightforward answers. That's our time. Our time thinks that these are simple answers. I've worked in ecology since 1968. And throughout my career, I have found that a few ideas have dominated people's beliefs about nature, which is the old-fashioned term for what we all call the environment. People feel strongly about the environment these days, and they always have. Why shouldn't they? When it's from the environment that we receive all of life's necessities, most of its dangers, and many of its pleasures. I want to talk to you tonight about what I believe we should think about global warming. Just to start by telling you what I'm going to tell you. I've done scientific research on global warming and its possible ecological effects since 1968, publishing my first scientific paper about it in 1973. At that time, only a few scientists were focusing on global warming, primarily some climatologists, meteorologists, and a few ecologists. Most of us knew each other. I read up about greenhouse gases and how they could warm the Earth. Of course, that insight's 200 years old. That's really fascinating, and people have been arguing about it for 200 years. I wondered how carbon dioxide, a trace gas in the atmosphere, could have any large effect on the climate when water vapor, also a greenhouse gas, was so much more abundant. I actually had to get into the physics and chemistry of small molecules in the atmosphere and study that, making use of my background in physics, so I could understand how that could happen. And I read the history of the idea. I was surprised to learn that early in the 19th century, people began to realize that burning fossil fuels might lead to a warming of the Earth. After all, carbon dioxide was only discovered by Priestley in 1770, and about 50 years later they were talking about a global warming. I was pretty impressed. That was good, rational thinking. By the late 1980s, I was working with climatologists on this issue. One of my graduate students did his PhD at the National Center for Atmospheric Research in Boulder, adding vegetation to one of the global climate models. And I worked with other groups about global climate modeling. So it isn't as if I haven't been involved in this. I don't think anybody can say I've lacked concern or involvement with global warming, or also, as I'll show you in my other information with slides, in biological diversity. And so you'd think I would be one of the strongest proponents of global warming's potential catastrophes. And at one time, perhaps I was. I gave many talks, wrote scientific papers, and discussed the likelihood of such catastrophes in several books. But no more. During the past 5 years, I have become deeply concerned about how global warming as an issue has gotten out of hand, gone way beyond science, and much of what is said about it has little basis in fact. I know that I say this at great risk these days, both professionally and personally. In fact, I experience that daily. Like some of my colleagues can't believe what I think about it. Just 2 days ago, a good friend and colleague said he didn't care if global warming was true or not because it served a good purpose. It was getting people to work together and realize that we are all connected through the environment globally, that we're all in this together. A week ago, I talked with the high school science teacher at my own high school, Croton-on-Hudson, New York, and he said pretty much the same thing. I raised questions about it, and he said, well, don't you agree that even if it isn't true, it's getting people to do good things? That's a fundamental break with the Cartesian idea of rationality, which is something that's deeply concerning to me, and I think it's likely to backfire. But this is ironic as well, because I believe I'm among the earliest modern ecologists to push for a planetary view of life on the Earth. I don't have time to go into that in detail, but I did help NASA start its mission to Earth, which became Earth System Science. And you could read my arguments in my books about the necessity, both scientific and humanistic, for that perspective, which, by the way, I still believe in. Now, and I will. So this is me in 1986 at the Mauna Loa Observatory, where Keeling, still alive, was making his really fascinating and important measurements of carbon dioxide. It's interesting that the government kept trying to cut off the funding for this because they couldn't see its importance, which brings up another theme of mine, which is, in my experience as a scientist, it's surprising how often the facts we need nobody's bothered about or been interested in. That even if the facts have been gathered, hardly anybody ever looks at them. And then if they do look at them, they don't bother to make some of the simplest calculations. It's a very ironic situation. I'm doing a book on energy, and I'm finding the same thing, and I'm going to talk about that tomorrow, about energy. So, not too many people were thinking about it. It's not that I'm proud of or trying to push this about myself, just saying that, I have been involved in this. I did think it was pretty important. And When I tell people I have some skepticism about what happens with global warming, they think that I must be anti-environmental. Because, of course, those people who don't want to believe that the environment is important are going to argue against global warming. And so we have these two extreme sides, and I'm trying to play the very difficult role of being in the middle. And I managed to upset everybody. So I have to make clear that my career has been based on trying to understand nature, how nature works, trying to help make the environment a better place, try to understand people's role in nature, and how we can bring these two together. And I also believe we should try to be rationalists and scientific as much as we could in our approach to these. Starting in the early 1970s, I started to work on endangered species. One of them was not yet endangered, but the first bird ever protected by international treaty involving the United States, the sandhill crane. 1916 treaty with Canada was to protect the sandhill crane. And by the 1970s, it had done so well that there were about 150,000 of them flying as one group and landing in farmers' cornfields, upsetting the farmers in the Midwest, who went to the Fish and Wildlife Service and said, for goodness sake, start a hunting program. And so the U.S. Fish and Wildlife Service set up a hunting program for them. And some conservationists came to me and said, we're concerned about the hunting that they're proposing, but we don't know how to make the calculations. And you know how to use computers and stuff, so could you help us? So I wrote a simple computer model of the population dynamics of sandhill cranes. And what I did was I took the data that the Fish and Wildlife Service was using. I said, there's very little data about these birds. And I don't trust the data itself, but these are the data on which policy is based. And I showed that based on the data about the population dynamics of the sandhill crane and the hunting level that the Fish and Wildlife Service was pushing, that the species would go extinct, that theoretical species would go extinct in 19 years. So, that was just showing the consequences of a policy basis from the federal government. And from that, then I got interested in endangered species in general and started to work on them. And then one of my colleagues decided it was too hard to work only on endangered species because being endangered, they were rare, there wasn't much data. So let's pick a species that's likely to get endangered but isn't yet, and that was the African elephant. So that's my favorite animal anyway, so I started to do work on the African elephant. But my point is that you're not looking at somebody who doesn't feel nature is valuable. Then, in the 1970s, I started to work on the bowhead whale. That was fascinating. One day, this young guy comes into my office at Woods Hole, which was a place where you were supposed to, the grubbier you looked, the more important you were. And he came in wearing a three-piece suit with a handkerchief in his pocket, and my assistant came over to me and said, there's some really strange guy, looks like a typewriter salesman. But he turned out to be an anthropologist who had one of the toughest and most amazing people I ever met, John Boxtos, an Arctic explorer and an expert on Eskimos. And he came to me and said, I've been studying the Eskimo culture, and in order to understand them, I had to understand their whaling. In order to understand their whaling, I had to understand Yankee whaling. And I've been able to recover the logbooks from many of the ships that hunted the bowhead. And I want to analyze them about the population of the bowheads. And Noah told me I had to find a biologist who would work on this with me. So I thought this was a great idea, and we've been working together ever since. And that's him, not me, but that's my colleague. And of course, this is one of the historic baleen stores from a bowhead whale, 19th century picture. The bowhead is an Arctic species, Pacific and North, and was hunted from 1849 to 1914. And so I did that, and that's continuing work. My thesis research was related to global environmental issues as well as pollution. I worked at Brookhaven National Laboratory in a radiated forest. Now, does anybody know that there were irradiated experiments with irradiating whole ecosystems? It's really amazing. This is what happens with major environmental issues. It's quite, many of them. After World War II and the dropping of the atom bomb, and Russia getting atom and hydrogen bombs, the federal government became concerned about the possible effects of nuclear war. And they set up 3 large experiments to look at the effects on natural ecosystems. One of which was at Brookhaven National Laboratory, which was a chronic exposure. They had a cesium-137 source, gamma radiation, that raised up out of the ground. It was on a post, came up 20 hours a day, and it irradiated this forest for 15 years. I was there about the 10th year. And every 4 hours a day it went down and was covered by lead shielding. And they said it was perfectly safe. Now, knowing my approach to approach to science and believing in Thoreau's approach, I didn't quite take their word for it, so I brought a Geiger counter out and stood over it and made sure that it was okay, which it was. Anyway, so I did research here on the possible environmental effects of ionizing radiation related to atomic weapons. And it was very striking. This is the forest that had been irradiated for about 10 years. And the odd thing about it is it looks like it just burned yesterday. But it's been dead for 10 years. And the reason is it's being sterilized every day, so the bacteria and fungi can't decay it. And so it was a very strange place to work in. Okay. And so then I got continuing my interest in global warming. I worked with some scientists at IBM, and we developed a computer model of forests. It was the first successful computer model of many species growing in a forest, and we did this in about 1970. And we actually had touch-screen animation, all the things that nobody knew about outside of the IBM Research Center, and it took about as much computing that would fill up this auditorium, including one computer that ran the model and another one that did all the graphics. And this computer model actually has worked quite well. It's used all over the world. And so in 1988, the EPA was asked by Congress to look at the possible effects of global warming on the environment. And so for 4 years, they funded some studies. And so we looked at this. I took the output from the climate models, temperature and precipitation, and put them as input into the forest. And one of the cases that I took, which interested me, was the Kirtland's warbler. Now, have any of you heard of this? You're all interested in oceans, so you may not have heard of it. Have any of you heard of the Kirtland's warbler? You have. Are you from Michigan? No, but you're an ornithology. You're a bird watcher. Yeah, okay. So the Kirtland's warbler is a very interesting species in that in the 1920s, Audubon Society had an article that said fire is the worst enemy of the Kirtland's warbler. That's because the warbler lived only in nests only in jack pine woods, and these burn. And so when they burned, it destroyed the nests. And so this is part of the Smokey the Bear thing, that fire is bad, disturbance is bad, nature should be constant. And so the Kirtland's warbler was the first bird ever subject to a complete census in the 1960s. And the ornithologists doing the counts were shocked to find in 5 years the number of warblers had dropped by half. And they began to puzzle why. And then they realized that's because if you don't let jack pine burn, it can't regenerate. Now, the birds nest in jack pine that's between 1 and 20 years old. The jack pine is a very short life species. It can't grow in the shade of other trees. It regenerates. It has cones which only open and release their seeds if they're heated by a fire, or a graduate student told me if it's in the back seat of a car that sits out in the sun, goes up to 120 degrees. And so it can't regenerate without fire, and even if you planted it under a forest, it couldn't grow because it's not tolerant of the shade. So the Audubon Society, Fish and Wildlife Service, and the state of Michigan got together. They set aside 38,000 acres, and they were burning this regularly in small patches to provide habitat. And this was helping the bird. And I thought, well, what's going to happen with global warming? What might happen to the jack pine forest? Because this is a really success story, but will global warming be the end of the success because jack pine won't be able to live where it lives? And the bird would only nest in jack pine on sandy soils in southern Michigan. Didn't like soils of any other kind. So this is what we did. We had the computer model that said if under the normal climate from these climate models, the jack pine, we had cut it, burned it every 30 years, and it would just grow back. So the model said, yeah, if the climate's the same, it grows back. And then we took the output from one of the standard models, Jim Hanson's NASA GIST model. And what it said was that if this model's forecast was correct and this forest model was correct, the Kirtland's warbler habitat should stop being able to grow by about 2000 now. And see, this actually got a lot of attention in the press. But, like the irradiated forest, nobody remembers this. And I wrote an op-ed piece that got published in the International Herald Tribune last year saying that, very few of the forecasts for global warming have been validated by experiment. And I said, I've been trying for years to get funding to go back and validate those forecasts, and I've never been able to get anybody to fund it. And I said, that's a curiosity, why doesn't anybody want to fund one of the clear possible tests of global warming effects? And it's a curiosity. It's one of those things where people don't really seem to want to know something that seems obvious, and I can discuss why I think there's not much interest in validating it, but it's a very strange thing. Okay. Now, that means I've done a lot of work about environment and including global warming. I have now I want to turn to what my concerns are about global warming and why. So I have about 20 more minutes, is that what you're saying? Well, okay. My concerns about global warming, what's being believed about global warming, is at two levels. One is the big picture level. How do we think about nature, and how do we think about people's role in nature? And the other is the specifics of specific research results. Okay, so I'm going to start with the big picture thing. Now, these are statements from the United Nations Framework Convention on Climate Change. The aim is to stabilize greenhouse gas emissions. That's the key word, stabilize, at a level that would prevent dangerous anthropogenic interference with the climate system. Now, this is Jim Hansen. You all know Jim Hansen's name, right? Yeah. Okay. And I know Jim Hansen some. I think he's a very well-meaning, sincere, and brave person to have gotten up and said what he said. But he's taking a particular point of view, which is in these words, stabilize and dangerous. Okay. Dangerous is not a scientific term, but it's in a scientific paper, and okay. Jim Lovelocker, any of you familiar with him? He's the Gaia guy. Okay. He wrote a book called The Revenge of Gaia. Now, I'll explain to you what this refers back to. And then Jim Hansen, and now everybody's talking about tipping points. Okay? Now, a tipping point is a very particular way of thinking about a system and about the world. These are my children illustrating tipping points. Okay. There's two kinds of tipping points, if you want to think about them: stable here, and unstable. A tipping point comes out of a view of a system as having a stable point where it stays, and it can fall off of that and drift away from its stability point. And Lovelock also pretty much has the same view of nature, except he says, well, it could have a couple stable states. Now, why am I concerned about that? I'm going to come back to that broad-based idea. Then I want to, because there's a whole worldview about nature that's implied in those words: stabilized, dangerous, and tipping point. Okay, I'll come back to that. Then, what happened in 2004? The New York Times got in touch with me. You know, major newspapers, they'll get a lead advance copy of an article that's going to be in a major scientific paper, Science or Nature. And then they'll ask the scientists to read it for them and give them some thoughts about it, perspective. So they sent me a paper by these people, Thomas et al., about global warming effects. And, you know, they knew that I'd done these things I was just telling you about with the Kirtland's warbler and all that. And so they sent me this paper which said, we predict on the basis of mid-range climate warming scenarios for 2050 that 15 to 37% of species, meaning they meant animals and plants, but I don't think they were really biologists, so I think they were talking about land animals and plants too, but that's they weren't talking about bacteria or anything. Species in our sample regions and taxa will be committed to extinction. That's a huge amount. I read the paper, and I was sorry to say that it was one of the two worst papers I'd ever read. Scientifically, terrible theory and lousy data. Now, I can go into the details about it, but if you want, but I don't have time tonight. A number of us got very concerned about it, and that this was going to get out because we thought the basis was so terrible. So a group of us got together, we organized an international meeting, and we brought people from all over the world, and we published a paper in Bioscience that reviewed the methods for forecasting. And I'll tell you about our conclusions but in a little while. But what I want to say is that our analyses were completely ignored, and if you look in the Intergovernmental Panel on Climate Change, you will find this assertion, approximately 20-30%. You can read it for yourself. Now, I want to make clear that this has almost no basis in fact. Okay. I can't go into the details right now. Now, that started me thinking something isn't right about this stuff. It's getting out of hand. Now, let's go back to the big ideas of tipping point, dangerous, and stable. See, I started working on the idea of nature in the 1980s. I got really fascinated because I was asked to advise the Marine Mammal Commission. In 1973, the United States government passed the Marine Mammal Protection Act, and it set up a scientific commission. The commission came to me and said that they didn't understand the basic wording in the Act. The Act said the primary goals of the Act are to protect the health and stability of marine ecosystems. Three terms which had no scientific definition: health, stability, and marine ecosystems at that time. And second to that, the goal was to have an optimum sustainable population of marine mammals. And they came to me and said, we don't understand what could be meant, and given the wording of this law, by an optimum sustainable population. And they gave me a contract to explain it to them, and I got together with an expert in certain kinds of mathematics. And we wrote them a report, which they didn't like, by the way, at all. But what fascinated me about it was that the scientists working on marine mammals were telling the government things that I knew they knew weren't true. I'm sorry, let me restate that. They knew that these were not consistent with the facts about marine mammals, but they believed them to be true. And I thought, these people are not intentionally being deceptive, but they really believe in a balance of nature. And I was finding this everywhere I went, that my ecological colleagues, down deep, really believed in a balance of nature. And this is an ancient idea. So I wrote a book called Discordant Harmonies about the idea of nature. Now, this idea of nature is well illustrated by the Hudson River School of Paintings. This is that painting by Bierstadt, Sunset in Yosemite. It illustrates the ancient classical idea about nature believed and written about by the Greeks and Romans, restated by the Judeo-Christian tradition. You find it in Jefferson's writing. You find it in the modern ecology. And the idea is that nature undisturbed by human beings achieves a permanency of form and structure, and without which, and it's only disturbed by human action. And if released from that disturbance, it will then recover. This was stated directly in 1864, just as I phrased it, by George Perkins Marsh in one of the first great books about nature called Man and Nature. The idea, as set down by the Greeks and Romans, and still very popular today, is that nature is constant, perfect, beautiful, and it has a great chain of being, a place for every creature and every creature in its place. Only people destroy its balance. Now, it's a lovely idea. The only problem with it is it isn't true. As Joseph Campbell said in one of his books about myth, he said that every society needs a mythology in the sense of a story about how the world came about and how it works. And he said the problem with our myth is that our nature myth is that it's 4,000 years old, and it's wrong. Okay. So what we know is that nature's always changing. The Kirkland's warbler knows that. And being adapted and evolving to change is necessary for living things on a non-steady state, always changing planet. And animals and plants are very good at this. They're invasive. They're very successful at it. And the real world is not steady state. There isn't such a thing as, it doesn't really mean anything to talk about stabilizing as if it were natural, because there isn't a stable state. So there's a world view that says it's dangerous to have changes, and this is the fundamental kind of thing that bothers me. And it leads to, what is the connection between people and nature? And we don't know quite where we fit in. It's a very odd thing. We know more about nature than anybody else has ever known, and yet we're the most confused of any culture I've read about in the history of people on the earth in terms of what our relation to nature would be. Almost every other civilization knew exactly what their relation to nature was. They may have been wrong, but they all agreed on it. We're confused. So, look, where do we fit in? The Greeks and Romans had a problem with this because they were sure nature was perfect. And then when it wasn't perfect, they had to explain it. Well, what's the explanation? It's the one you'll all know. It always points the finger at people. Either we were supposed to be the final cog, or final wheels in the machine of nature, and we didn't do our job. We aren't playing our role. Or it was perfect without us, so anything we do screws it up. That's destabilizing dangerously and creating a tipping point. And we really don't know where we really fit in. We have these various ideas. This is one of I love this painting called American Progress. And if you look at it, it's really lovely. This is progress. It's really a lot of fun. And
Where are the Indians?
The Indians are in the darkness with the bad animals. You have to look. And she's carrying a book that says knowledge, and she has a telephone wire in her hand. And it's just a great idea. But the Indians are there. You just can't quite see them in this. Okay, American Progress. So is that where we fit in? Or this is another painting. The painting of times reveals a lot of how people are feeling and thinking. This is the modern global warming view. This is us. Just we're screwing everything up. Okay, we don't like change. It's very uncomfortable to live with change. We all want it to be the way we grew up. I'm not any different from that. Just very quickly, this perfection was not only temporal; it had to be spatial. The Greeks said that the deepest point in the ocean would be exactly as deep as the tallest mountain because nature had to be symmetric. And when Lewis and Clark started on their route, they got the best available maps from a man named Arrowsmith, and he said that the western mountains had to be identical, symmetric, with the Appalachians. And he wrote this because this was had to be what they were going to be. And I love it because he says they couldn't be more than 3,520 feet high. And I love the idea that if you're going to be wrong, you might as well be wrong very precisely. Okay. But, and of course, this wasn't the way it was, and this almost caused the death of all the Lewis and Clark, misunderstanding that this was not a symmetric thing. So there are consequences of this. Now, I'm running out of time here, so I'm going to jump over some stuff. I did believe in the balance of nature when I first started my work. We did a study of wilderness, Isle Royale National Park with moose and wolves, and we really did believe. We went out to see how the balance was achieved, and it turned out there wasn't any balance. So I'm going to go a little bit quickly through this. I want to get to my concerns now about global warming. Let me just go. Okay. So, because I'm only going to have a few more minutes, right? So, okay. So here I have this background thing that a lot of the arguments about global warming are based on this premise that nature undisturbed is constant, and we're messing it up, we're changing it, and that's dangerous. Now that's just not the way nature's been. Now going back to that forecast that 15 to almost 30% of species are going to be in trouble, we went back and when we did this analysis, we said that there's a quaternary conundrum. The quaternary is the most recent geologic period. And we said that while these forecasts are saying a lot of species are going to be extinct, the odd thing is that almost nothing went extinct in the last 2.5 million years. Some big megafauna in North America and Europe did, and about a third of the woody plants in Europe did, but outside of that, around the world, essentially nothing happened. So the facts are not consistent. Okay. I gave this talk at Oxford University, and a woman came over to me, Professor Sarah Randolph. She said, I'm experiencing exactly the same thing you are. I work on epidemiology, and I published papers that looking at the possibility, which you see in a lot of the global warming literature, that tropical diseases are going to spread because of the warming. And she said it turns out that doing careful statistical analysis about the distribution of malaria involving multiple factors, that temperature is not a good predictor of malaria. And she says it's very naive in to think that something as complicated as malaria is going to be accounted for primarily by one variable. And she said it really isn't going to spread with global warming. But this is not in the IPCC reports, and you keep hearing this assertion. And there are other studies about encephalitis that says that also isn't going to spread. Okay, so now what about this Arctic sea ice area? Well, so with all this now, I've really gotten involved in going back over the information. So there's a recent paper that's a very careful study about the Arctic ice. And it's very interesting. See, everywhere you hear the Arctic ice is disappearing, but it's much more complicated than that. This says, well, it declined 2.2% between 1979 and 1999, and then it increased by 0.8%. And also, that it's now becoming quite prevalent now that the variation in the Arctic sea ice appears to be, according to the people who are experts on this, more a function of periodic oscillatory phenomena between the atmosphere and the oceans, and is not primarily due to global warming. But this answer isn't 100% here. And so if you take a rationalist point of view, you're somewhere in the middle, at least, or somewhat looking at this and saying, gee, that's really interesting. And so as a believer in rationalism, I went back to the whaling ship logbooks and realized that we had 65,000 days on which whalers actually wrote down what was happening on all of these, take all these ships for 70 years, and on 23,000 of them they saw sea ice. So there are very few ways to get back before satellite remote sensing about sea ice extent. And so we now have a project to use these logbooks to look how far south the sea ice got. So, it's not that I'm not trying to work on global warming or just dismissing it. I'm just concerned that we're over-interpreting things. Now, Mount Kilimanjaro has been one of the poster children about global warming, but there was a wonderful, thoughtful article in the American Scientist last year that said, gave the whole story, which was this glacier became very big in the 19th centuries because of very wet periods, and it had been declining since the late 19th century. It wasn't just happening. And that the temperature at the elevation of the glacier is below zero, so it can't be melting from global warming. And he then goes into a very interesting discussion about the shape of a glacier that's melting from sunlight and the shape of a glacier that's melting from temperature. And this one is melting in a shape that can only be from sunlight. So he says this is not a global warming phenomenon. Now, are there other Arctic alpine glaciers that are disappearing because of global warming? Well, probably there are. But, okay. And I'll end up with the polar bear and then open it up to questions. So, polar bears. Okay, I've done a lot of work on endangered species. The standard thing was that by people experts in genetics and population ecology, there has been, now you can discount it if you want, that a species wasn't really to be considered endangered, a vertebrate, until it got down to 500 or less. And it could even get down to 50 for 10 years or so. Now, the polar bear, the numbers are somewhere between 18,000 and 23,000. But I've been in contact with the top people in counting polar bears, and I've got the data. It's not counted consistently. There's 19 different populations. One was counted in 1984, another was counted in 1994, another counted in 2004. There's no way you can get a trend out of this. And there's plenty of them. Meanwhile, there are lots of species that are really endangered. So my friends say, well, so what if the global warming stuff isn't really true? It's getting people to think and do good things. Why be concerned about it? Well, one of the things is I'm concerned that the species that are really endangered are getting left out, and the poster child ones are not. So, if you really want to be concerned about a big mammal, how about the tigers or orangutans? Now, also, the polar bear evolved several 100,000 years ago. The experts are not certain, about 300,000 years ago, from grizzly bears, and they have survived periods that climatologists now believe are as warm or warmer or faster than has happened now. So they have survived these kind of things. I'll skip through this. Meanwhile, there are really important problems that are not going away. Here's just a few. I was just at a conference on invasive species. Now, you want something scary. There's a new bacterial disease and its insect spreader from Asia that has called citrus greening that has gotten to Florida. And it's wherever it's gotten, it has pretty much destroyed commercial citrus growing without a lot of use of pesticides and kinds of actions that we don't like to do. So the experts from the U.S. Department of Agriculture were telling me, and the other people in the audience, that this might be the end of citrus commercial production in Florida. Well, that's important. And then here, we're really over-harvesting fish. I'll talk about that another day. We really have to think of ways to get away from oil and gas and coal as well. And so, there's many real problems. So what I want to leave you with is that we haven't yet really worked out how to think about nature correctly. And I'm concerned that our broad view of it is the ancient myth of the balance of nature, which will lead us astray. And also that many of the specifics about global warming have little basis in fact and appear contradicted by good studies. And so I'm afraid that we're going way overboard about this and that we need to back off and focus on some of the really important issues. But I find myself in a vast minority saying that, and I appreciate the opportunity to say this to you and would love to discuss it with you. Thank you very much.